Thank you, Charles, and welcome to this talk in conversation with Mike Joyce, from the President and CEO of PrimaLoft. We will be discussing the rich innovation and performance heritage of a company that has arguably been a pioneer in many fields. Biodegradability comes to mind, in addition to recycled content. During this talk, we will try to get Mike to reveal a few details about the next generation of innovative products the company is working on, and I'll ask him to have short answers so that we have time afterwards for the audience to ask questions. In any case, please feel free to interrupt at any time during our talk. So let's start today. We're here to see what PrimaLoft has in its innovation, performance, and sustainability pipeline. Can you tell us how all 3 points are linked in the way you work at PrimaLoft?
Sure, absolutely. Hi, everybody. We really look at the purpose of the company really is to unleash the full potential of people, products, and the planet. And that's our purpose. It's not just, it is product, but it's about doing it in the right way. And we really focus on 3 concepts: innovation, performance, and sustainability, and all in balance. We believe that you can have innovation and performance without sacrificing on sustainability. You can have it all. And we really think about that through advanced material technology. If you can change the performance of the material, you can change the performance of the final garment. And the way we construct it, it's not a linear process for us, it's a circular process. And we think about it through what we call our relentlessly responsible model. And it starts at the 1 o'clock position, which is about what materials do we put in place? What materials do we use? Currently, about 90% of the fibers that we use for our products are made from recycled materials. So we start with a sustainable input. We produce those materials using our pure processing technology where we minimize the carbon footprint of how we make products. The most important component of any sustainability program is durability, and it's often forgotten. We work on very complicated solutions, but number 1 solution would be make products that last a lifetime. So our products are high performance. As you move around the circle, if the event of materials getting in the environment, and what we think about is fibers that get freed up in washing or drying, if it does get into the environment, how can we modify the material so that it returns to natural materials? We're talking about biodegradation. And then lastly, as you come up the top of the circle, is our products are made to be circular enabled. In other words, chemical recycled, so that we go back into the stream again and around we go.
Thank you. So let's talk about recycled content. Let's start with that. Recycled polyester comes mostly from beverage bottles, and that has become a standard. How is this part of the PrimaLoft product journey, and what's next? Are we going to be relying on bottles forever or not?
No, we're not going to be relying on bottles forever. It is the solution that's available today.
True.
It is mechanically recycled, so therefore the carbon footprint is significantly below that of virgin polyester materials, but it's not the long-term solution. The long-term solution is to change the inputs and move out of mechanically recycled materials, which you can have only one time through,
yeah,
and move to other alternative materials. We are working currently on a technology where we change the source of the material from crude oil to cellulosic fiber.
Right.
It's not a biopolymer. What we're working on is extracting the carbon from cellulose, old paper, box board, waste paper, extracting the carbon and using that as opposed to crude oil to make the chemistries that make the polyesters. So we're shutting the valve off on the crude oil and we're making it through renewable cellulosic feedstock. And that, I think, is the next step.
Interesting. Okay. And so, well, let's move on and talk about carbon neutrality. So this is an important issue for PrimaLoft, I understand, and you're tackling it from two sides. So there's the manufacturing. Can you tell us about PrimaLoft Pure, and how does this reduce the company's carbon footprint? Is it just about investing in new machinery, or is there more to this carbon neutral journey?
It's an intricate process where the word pure, our product pure, stands for produced using reduced emissions. This is a combination of the materials we choose and recipes we choose, as well as the equipment to make the product. So we can move off of coal or natural gas sourced energy and move towards alternative energy methods.
Right.
In our process, the largest consumer of energy is the thermal setting ovens. And those are often powered through coal or natural gas. So as we move that over to alternative energy, we have to change the product so that the product is enabled to be produced that way. So it's a combination.
Right.
And by doing so, we've been able to reduce our carbon footprint between 50 and 70% by doing it this way.
That's impressive. Yeah. And so there's also the matter of carbon neutral materials. And so you are working with an American company called Origin Materials. Can you tell us more about this partnership and what we can expect to see?
Right. This is referring to the previous product I talked about using cellulosic feedstock. There's a company called Origin Material. They make a chemical called paraxylene. I won't bore you over all the chemistry. But it's really a crude oil generated material. And we're swapping out cellulose carbon for the crude oil. Now, that paraxylene, doing it that way, becomes carbon negative. Well, how does it get to be carbon negative? If you think about it, we're talking about cellulose, wood. Go back to your 5th grade science class on photosynthesis. The tree absorbs the CO2, gives off oxygen, and the carbon is sequestered in the tree cell.
Okay.
Origin Material is extracting that sequestered carbon to make the material that makes polyester. I'm convinced that we'll never get to carbon zero by the methods we're using now, which is crude oil-based materials, because your carbon footprint from the beginning is quite large. By creating a product that has a negative carbon footprint to begin with, we have a better chance to keep the additive carbon footprint as low as we can and get to carbon neutral.
Wow. How far away is that?
We've made fiber. We're in the process of scale. So we're thinking 2026, 2027. It's not that far away. It seems that way, but it's not.
Pretty good. Okay. Moving on, let's talk about biodegradability. So you've been in this space for a long time, launched the first biodegradable installation in 2018. What was the intent? Were you looking to address the end of life of a product or reduce possibly the impact of microfiber release during a product's use? And which of these two functions or messages is the most important or has the most draws the most engagement from your direct customers within the industry and then also from consumers at the end of the line?
There is no doubt that the focus here is microplastics. It's not end of use. As I said earlier, we make products to last a lifetime. And that's the number one thing that we all should do around sustainability is making very durable products. This is about the microplastics that will eventually happen in wear and tear and everyday use and wash and wear. So that if the material does get into a landfill, into marine environment, or even in wastewater, we have a technology that allows that material to revert back to natural materials, back to, carbon.
Right.
And so this is a microplastic. I don't think bio is the long-term solution, but it's the solution we have today as we look towards the next solution for tomorrow.
Okay, interesting. And then there's also the matter of getting that message across, because there are different norms, different standards in the U.S., in Europe. How complex is it to get that message across?
It's very complex when it comes to the consumer messaging. The science is real. The science is proven. The brands understand it. It's how do you communicate that to a consumer? We're not saying that your garment is going to biodegrade in the closet. We're not asking you to bury it in the backyard. It's really about if the material gets into the environment, does it turn into natural materials? So that it's a challenge. Some of the government communication restrictions are not keeping up with innovation, right? So I hear in some countries and some states that plastics are not biodegradable. That's just not true.
Okay.
Just not true. So it has been complicated. It's very complicated. But what we're trying to convey to the consumer is that through wear and tear and microplastics, this will minimize microplastics by accelerating the degradation process.
Yeah, yeah. I suppose it adds a greener message to synthetics. That whatever, yeah.
For sure.
So easy. So anyway, moving on. Let's talk about innovation in product and innovation in formats. So this is about PrimaLoft Insulation Thermoplume, which was launched 5 years ago. How successful has it been? What's new in that space? And I'm also curious to know, what is the best use case scenario? Is it best for the very puffy jackets or slim fit jackets, or can it work for everything?
So Thermoplume was launched several years ago. It's our luxury down alternative is what we refer to it as. It's, I believe, the most down-like synthetic. It's fully blowable. And it looks and feels like down. And so what we were trying to do is address, not only an enormous market, but we're trying to address the animal cruelty issues.
That's right.
That is real. So this is vegan. Some will say that's vegan. And we've perfected the look and the feel of it so then you can substitute what has normally been used for down.
Right.
We've now recently made it 100% recycled. And we add our biodegradation technology into it. So now we have this more robust solution to down. But make no mistake, down is very difficult to copy. It has millions of years of evolution.
I can imagine, yeah.
So, and we're trying to replace it.
Are you working on a new product in that line?
We are constantly working on the next best solution to down.
Right. Okay. Well, that covers most of the points I wanted to cover with you. Does anyone in the audience have a question for Mike?
Can I just interrupt? Mike, I said earlier Mike makes me think. What you said there about using sequestered carbon, can I just say wow?
Yeah.
I've seen people, the Iceland project, where we're taking carbon dioxide, reversing the photosynthesis, but using carbon sequestered already, wow. That's just an observation from Charles. I'm not good enough to think of a further question. It's time for audience questions. Does anyone want to pick on Mike or Sophie? We've got a question at the back.
Okay.
Thank you, Ben.
Hi, thanks so much, really enlightening. Just a question about the biodegradability of products. You said that in the future, or all plastics could be biodegradable, but under what conditions and what must we do in order for them to be so?
We can barely hear you.
Oh, I'm sorry.
Yeah,
Right,
you say the second half of that question.
So, I was asking about the biodegradability of plastics. You said earlier that all plastics could be made biodegradable. And I wanted to know what it was that made them so, and indeed, if they were so, and they could be made so, shouldn't they all be biodegradable?
That's a complex question. The answer is yes. All of them. When we've been successful in biodegrading polyesters, polypropylene, polyethylenes, elastanes. So we're covering a whole family of products. The way it's working though is the product has to be in the right environment where microorganisms reside, right? Wastewater, marine conditions, and landfill. And those microorganisms naturally occur. What's very important about our technology, it's not oxo. We don't do oxo degradation. That's worse, because that creates microplastics. We're not using UV degradation. We're using hydrolytic. And then what happens is the microorganisms then dissolve and eat away at that polyester, break it down, and then it returns to materials that are natural, such as biomass, which is more like almost like a humus material, a potting soil kind of material. Our work, we've done the work so that we've tested it for toxicity. There is no polyester remnant. There's no heavy metals. And we've passed a germination test, so the material will actually grow life. So we've gone through all these processes to make sure that this really does what we want it to do. And so now we're moving into polypropylene, polyethylene, and we're going to continue that process. The last point I want to make is we're so serious about this is we've invested in a biodegradation lab at a university, the University of Massachusetts, in their School of Marine Science and Technology. And they study marine environments. And we've put in a state-of-the-art biodegradation lab so that we can get academia to enter into this process and help us research the next solutions for a myriad of problems. Plastics for sure, but they're also looking at tire dust and how that impacts the waterways and how do we biodegrade the other pollutants. So we're not just about apparel. We're really looking at a larger scale solution. Thank you.
Mike's a bit too polite. Can I just re-emphasize a point Mike's made? Because he flew over it really quickly. When we have decomposing synthetics, one of the biggest hassles you find is that it just breaks the toxic mess into lots of small parts. By having non-toxic remains, it's a major step forward. And the industry, you'll see a lot of decomposition signs. They won't tell you how quick it is. Now remember, polyester lasts 200-300 years, and at maximum they increase the degradation by tenfold. So they're still lasting decades. We're talking years. It's measured in 2 years. Yep. But more importantly, there's a non-toxic biomass. So I'll do the bits Mike's missed.
Thanks, Charles. The microplastics problem is enormous. There's about 8 metric tons of textiles that go into our waterways, of which the majority of it is microplastics. Is this the ultimate solution? No, but it's the best solution we have today. And so I'll grab that and we'll go with it until the next best solution comes. And we'll take that as we progress. This is a journey. It took us 60 years to get into this problem. It's going to take us a while to get out. So if we can minimize the amount of time these plastics are in the waterways, it's going to improve the environment.
And we can take an additional question if anyone wants to ask. Oh, come on, look, Ben gave a really good question that challenged Mike. Does anyone else want to pick on Sophie or Mike? In which case, can I ask you to show your appreciation for our dynamic duo, please? The next presentation is by a bloke called Charles, and it's on consumption, which was the big subject of the European Outdoor Summit, and it will start in about 5 minutes' time. 5 minutes' time, Charles on stage talking about consumption, which is the big ugly question.